Welcome back students to my channel The Blue Ink. So today we will be taking up another interesting topic of accelerated vessel, and in upcoming videos and in this video we will be taking only accelerated vessel conditions. We will be covering A to Z of this type of problems, and we will be covering all the cases and concepts in the form of problems. I hope you have already watched my earlier videos, as those videos will be providing a solid concept for upcoming difficult topics. So let's start with our topic accelerated vessel without wasting any time. So at home today you do an experiment. Take a water bottle and partially fill it with water. Give it a jerk and observe the motion of the water. When you will give bottle a small jerk, the water surface inclines itself like this. You observe that. Be precise in observation, you will definitely see this motion, and after that it will though it will start oscillating, but for some time you will see this type of motion as well. So please do observe it. So let's start without wasting further time. So on accelerating this vessel, the water surface inclines like this with some angle theta with the horizontal, and I have already written some of the points and we will be quickly going through them. So let us quickly analyze the point and I will be explaining them one by one. So all the observations must be carried out in frame of vessel. So first we will be taking this point and we will be analyzing what it says. So actually we will be observing and solving all the cases in frame of vessel. Means we will be making this vessel at rest and we will be analyzing the water only. So how we will be doing it? So I hope you have a thorough idea of relative motion. So we will be taking out the same concept here also. So consider a point, suppose on the surface of water, you can take anywhere, consider this point. Now the acceleration of this point with respect to this vessel, we have to find acceleration of this point with respect to vessel. How we can write that? So by relative motion we know that acceleration of any point P with respect to vessel is AP with respect to ground minus AV with respect to ground. That means acceleration of any point with respect to vessel is acceleration of point with respect to ground minus acceleration of vessel with respect to ground. So, and this equation is I am applying along horizontal direction. Okay, means along x-axis. So let us find this, because we are interested in observing the whole situation in vessel's frame. So we will be making the vessel at rest actually by using this relative motion. So acceleration of point P with respect to vessel is, see, acceleration of point with respect to ground. When I will be observing by standing here, this point will actually be looking at rest with respect to ground. Okay, so its velocity with respect to ground will be 0. The acceleration of point P with respect to, suppose this is P, the point P with respect to ground, it will be 0, minus acceleration of vessel with respect to ground. Now you can clearly see the acceleration of vessel with respect to ground is A. When I will be standing on the ground and analyzing the motion of vessel, it will be going horizontally with acceleration A. So it is A and it's in the positive direction. So from here the acceleration of P, point P with respect to vessel is minus A actually. That means if we will take out this whole section of water and make it here, the acceleration of this point will be like this, because it's negative sign means with respect to vessel, means the when the vessel is at rest, the point have the tendency to move like this. It will also have a g along y direction, which is always present, so I am not pointing out it. So that clearly means that not this point, means the whole water section, every point will be moving with the acceleration a in the negative x direction, means in opposite direction. This means this whole section of water will be moving in opposite direction when we are in the frame of vessel. So why we are doing this, that we are observing the motion in frame of reference, because to find this theta, to find the pressure, it will be much easier in the frame of the vessel. So always make the vessel at rest. The vessel may be accelerating in any direction. First of all, what's your job is to make the vessel at rest by just reversing the direction of acceleration. I will be taking some questions or some problems of this, of I will be accelerating this vessel in different directions, so let's take them as well. So take this case, we will be taking this case. See the now the vessel has been accelerated like this. I am accelerating the whole vessel like this. So now we have to observe this situation in the frame of vessel. So what you will be doing, just reverse the direction of acceleration. So this is water column, and we will be just reversing the direction of acceleration. Means this water column, when the vessel is at rest, will have the tendency to move here. Okay, or you can do one thing, take the component along AY, this is AX, and along vertical direction it will be AY. Just reverse one by one now to observe in the frame of vessel. Reverse this will be AX, and reverse this one, it will be AY. Okay, so net will be again this only, A only. So now we are in the frame of vessel. So always you have to do this. I hope with this example it is clear.